Well, first off, I'm really excited to give this talk. And secondly, thank you all so very much because it is the last session of the day. So I appreciate actually seeing people out in the audience. This is great. I've done this talk a few times before, earlier versions of it. However, this is a rapidly evolving part of the industry with respect to AI. And so I've been trying to go along week by week and add in new case studies or links or other factoids or update things as I could. And even as I was walking across the hallway into the room here, a good friend of mine, Anurun Kul, who was speaking earlier, I believe today or yesterday, came up with a different case study. So I didn't have time to make a slide for that one, though. Alrighty, so best practices for human in the loop. And this is tilted more toward the business side of it, although I think that there's a lot of technical depth here too. How many people in the room are more from the business side of the house? Okay, good, that's like 60%, let's say. How about the technical side of the house? Okay, and I know there's other sides of the house too. Hopefully at least 3 or 4. So first off, I wanted to just give an introduction if you haven't heard of this kind of area before. So a few definitions. Machine learning, we often talk about supervised machine learning. So when you hear algorithms being discussed in machine learning, much of the dialogue is about supervised. And supervised is where you have a data set, you have some labels that you will use for training. Probably you do a holdout where you take part of that data set and train a model. You learn a model, and then you go and use the rest of the data set as a holdout to evaluate it. Now, deep learning is, of course, a very popular example of this, and ergo the need for having lots of labeled data in deep learning. This is typically what people are talking about. There's another category, though, of unsupervised machine learning. You've probably heard about this some in terms of, say, k-means or PAM or other types of clustering algorithms and related approaches that are similar to that. Typically, they're looking to find some kind of latent structure within your data. So whether you're segmenting customers or, well, just different types of clustering, I guess probably fit that as well. It doesn't require labels. And it also runs in a fairly automatic way, ergo the name unsupervised. It's really interesting work, and a lot can be done with it, but it's not the typical kind of models that we talk about for AI. Using unsupervised approaches for AI is kind of an open question, but there's definitely some good efforts. It can be monstrous at times, ergo the Cthulhuoid monster on the side. And so I just wanted to show those as contrast because there's also different flavors of semi-supervised machine learning. And one of these in particular, a special case, is called active learning. And that should be distinguished. You'll also hear active learning. It's used in terms of pedagogy. And I had the unfortunate circumstance of going and speaking with a friend at a small conference where the other speaker was talking about pedagogy and I was speaking about machine learning. So we had an active learning seminar, but we're talking about different things. Active learning is where, think of this, if you can use machine learning to detect a pattern or decide a label. If you can do that with high confidence, then take that. That's a kind of automation. It's basically supervised learning. But if the models come back and they have low confidence, basically they're uncertain, then kick that back to an expert. And so you get the expert to weigh in, and that's a good way of finding what are the more valuable parts of the data that need to be labeled, because obviously this one has a use case. So you're doing a couple things there. You're engaging people who are experts into this kind of human-in-the-loop scenario, and you're also helping to label more of your data. This works well in cases where you have lots of inexpensive, unlabeled data, which is pretty much the norm. Maybe norm is the wrong word. It's pretty much what you see most of the time. And the other thing is, it's also more of a priority when the cost of labeling can be considered a major expense. So anytime that you can run in an automated fashion and get good confidence, go with that. But if you need to pull in the experts and take their time, of course, that's going to be slower, probably more expensive. But it does help you to clarify your data. One of the benefits of using this kind of approach is you'll probably hear this notion of explore, exploit. Danny Lang had a fantastic talk about artificial general intelligence and sort of looking at explore, exploit in terms of biology and organisms conserving their energy and fighting against entropy. Here, what we're doing is exploring and exploiting uncertainty. And I think it's really interesting in a business context to look at this and see how it's used, because uncertainty has a lot of meaning in business, and we'll explore that. There's a couple of articles. One of them was, I guess about a year ago, and that was on Domino Data Lab, Humans in the Loop, and then a subsequent set of articles, a couple of them were picked up by George Anadotis out of ZDNet in London. So if you want to read more, that's got a lot more links. There's a couple of articles that can go into some depth on this, but these slides here, I'll be making these public, and they have, of course, a lot of links in them as well. So from the business side, I definitely want to consider, I made the mistake of studying AI in grad school like 35 years ago, or more, I guess I should say, way before it was anything that was going to be practical or we had any kind of hardware that was reasonable. But back then, we weren't just talking about neural networks. We definitely were, and I was lucky I got to go spend about 7 years of my career doing R&D in neural networks. But we were also talking about other things like knowledge graph and planning systems and scheduling systems and ways of leveraging operations research for optimization, different types of learning. Again, I'll reference, I mentioned Danny Lang, but if you didn't see that talk, take a look at the video because he talks about a variety of different types of learning, like imitation learning, for instance. What I'm trying to say is deep learning is not the end-all be-all. There's a lot of other areas of AI, and through this conference, we're trying to track which of these are really getting traction in the ecosystem. Definitely, it looks like knowledge graph is bubbling up. We saw talks this year. Active learning is also bubbling up. We saw, I think at the last count, there were about a half dozen talks at the conference about active learning and human in the loop. So I definitely referenced some of those. Another thing about AI, it's not just about the algorithms. It really is about teams of people and machines. And there are places that we can go look and find decades of work and learning toward what's our guidance on how to develop systems of people and machines together. And with that, how do we do that integration? What kind of methodologies do we follow, et cetera? So I wanted to show a few indications. Number one, just as a definition, I really loved this article from Microsoft a couple years ago. And by the way, as a personal goal, I've tried to make sure that the links here are no more than about 3 years old. So everything's pretty current, a few historical items. This one's from about 2 years ago, where Microsoft announced Microsoft Research had beat the human benchmarks for speech to text. And it's interesting because they got above 95%. There's a kind of human threshold where human experts doing speech to text transcription usually start to hit the skids at about 95% accuracy. And something that's interesting when you look across here is that human threshold of 5% error, it's not just in speech to text. We see it over and over in different domains. There's a point where the human experts, if they're good, tend to agree with each other, and beyond that point, they tend to disagree with each other. So it's not that humans necessarily have this failing that they can't get better than 95% accuracy, but it's more like there's a lot of uncertainty out in the top percentiles where being an expert means that you're opinionated. So it's interesting where we start to introduce AI into that as well. Okay, so that's a definition for AI that I'll work with, and I think it's very interesting to understand that relationship between experts and machines. Another thing on the business side is segmentation of the industry. Taking a look at AI adoption, and this is coming off of a MIT Sloan management review report from about a year ago, where they were showing some segmentation, some trends. I think that there's some McKinsey Global Institute reports floating around that also tend to concur with some of the numbers. But basically, we can think of the industry in terms of 3 segments. There are the unicorns, the companies that are the prime movers in AI, and they have cloud, and they have great AI teams. They have a wealth of data, and they've been leveraging strategies to collect a lot of labeled data for a long time, and they have a lot of advantage. There's also a couple of large segments. We could say that there's the adopters and there's legacy. For the adopters, out of the reports over the past year, the adopters tend to face similar challenges. They've got the talent crunch that we all face. They've got competing priorities for investments because they're worried about data privacy and security and compliance, things like that. Sometimes that gets in the way of their AI efforts, but hopefully there's ways around it. And they're also worried about seeing verticals getting eroded from the incumbents, which of course is in the news a whole lot. Now, human-in-the-loop active learning provides some pretty interesting approaches for the early adopters in enterprise for AI. It gives them some competitive advantage against the incumbents, against the unicorns. And so we'll try to explore that. The other segment, though, is more legacy, and there's a lot of businesses where they might have a great AI business use case, but they wouldn't recognize it if you put it right in front of them. And this is what the reports are seeing over and over. This is what a lot of the consulting firms are reporting. And there's a problem that a lot of organizations are really buried in tech debt, and they're trying to get away from that. You really have to have your ducks in a row with your digital infrastructure before you can start to do a lot with data science, before you can start to do a lot with AI. And it really has to happen in that order. There's no real shortcuts to AI. So if your organization is struggling to get out of tech debt because of your digital infrastructure, AI is still a few years off. And that's a problem because this evolution is happening quickly, and waiting for the next few years to begin a path toward AI adoption in enterprise might be a crucial mistake. And the other thing, too, is that in a lot of organizations on the legacy column there, or row, they just really don't have the management buy-in to do these kinds of projects. Now, what's interesting looking at the reports is they tend to agree the adopter category is roughly about 50%, and the legacy category is about also there. Actually, the adopter is slightly larger, but we're looking at about 50 and 50, and then just a handful of unicorns. So that does mean, though, that about 50% of enterprise is in the legacy part and really at risk. Along with that, as far as segments for AI adoption, Ben Lorica and I did a survey, which it was meant to be a small survey, and it accidentally went out to many thousands of people. And so we got 8,000 respondents worldwide about machine learning in enterprise. And so we tried to draw some conclusions from that. It's a free mini book. I may be jumping the gun. I think this is supposed to be for London or New York or London or something, but the download's available if you want to grab it. So it kind of fits into some of the themes and changes that we're seeing. Number 3. Now this is interesting and maybe a little provocative. Anybody know who Ron Jeffries is? A couple of people. Okay, great. So Ron Jeffries, he had helped create something called Extreme Programming, one of the original people in terms of the Agile Manifesto. So if you've seen practices like Scrum, he's one of the people who created that. And here he is talking this year about developers should abandon Agile, and it really comes down to, Agile was an interesting thing in February of 2001, and it's certainly taken the industry by storm. But there were some intentions there when they articulated that of what they were trying to accomplish. And some of the original architects of Agile are coming back now and saying, look, we've really drifted far away from the original intent. And so to wit, 20 years ago, Agile was really creating value because you had teams iterating on a code base and doing a lot of rapid iteration on a code base. And at the time, data was just something, you ran it through your web app, right? It might be in your database, it's specified by a schema, but you've got some unit tests for it, but it didn't have the significance that it has now because of things like deep learning and the arc that we've seen since 2013. So another thing is just open source. A lot of the economics have shifted. You get a lot of return on investment for being involved in open source. Basically, a lot of enterprise uses open source, but realistically now somebody else maintains your code base for a lot of it. And what you really need to worry about is what you're doing with your data instead. And the code isn't necessarily going to give you a lot of value unless you've got all that great labeled data. So a lot of the economics of Agile have kind of changed, and they don't necessarily apply in AI. That's one of the things that we found when we were surveying about AI adoption around the world. Okay, number 4, data rates. This is a really good talk by Jeff Dean at VentureBeat Summit last year. And basically just underscoring the point that we talk a lot about deep learning, and it's great to do deep learning if you have hundreds of thousands of labeled data points. If you only have 10 examples of data points, deep learning is not going to help you. And I teach courses in NLP, and that's one of the things we do is we take and train a data set with deep learning, and we have hundreds of examples, and it does so-so. And then we throw in a few million examples, and it does great. So you try to underscore the fact that the scale of data is important. Putting that scale onto a log scale, supervised learning, the algorithms we talk about, if you have hundreds of data points, great, you can start doing some supervised learning. Deep learning, typically you want to see hundreds of thousands into millions, really, before you start to get good convergence. Reinforcement learning is going to be a couple of orders of magnitude beyond that. Active learning is something that's still applicable even with lower data rates. And so for a lot of enterprise use cases, you may not have a lot of labeled data yet, so this is something that's very much indicated based on data, the reality of the data rates. And along with that, how many people have seen this new thing that came out of DARPA? Really, it's only a couple months ago. But it's an initiative out of DARPA where they're saying, look, in the kind of use cases that we have, the things that we really care about, we may only be able to see 5 or 10 times before they begin firing missiles at us. So it would help if we don't have to wait to have millions of examples before we do our deep learning training, is basically what they're saying. So things like K-shot and transfer learning, different areas of meta learning, active learning, et cetera, are being encouraged for part of this new challenge out of DARPA. And then lastly, I thought there was a great talk, if you didn't catch it, at the keynote yesterday by Kai-Fu Lee, where he showed the quadrants of optimization versus compassion, and where is it that you get AI and humans working together, and where are really the priorities for that mix. I thought that was a really brilliant view. To put this another way, though, there's a lot of learning that comes out of the field of second-order cybernetics, and where that overlaps into, say, design. And certainly this applies here. I'll dig into this a little bit more depth, but here's a couple of more recent articles about this. Maybe Ranulph Glanville is not quite as recent, but it's still very salient. And the idea there is that rather than thinking of input, output, and some sort of black box in between, we should be thinking about feedback loops. And in enterprise especially, when you've got large teams, a lot of different customers, you should be thinking about multiple feedback loops and how to manage those and leverage those. So there's a lot of learnings out of cybernetics that come into play. Okay, so active learning, I promised some case studies. And the best way to do this is, of course, with the NASCAR slides. So I've been carefully curating a NASCAR slide of a lot of different companies that are kind of in the game here. And I'll go through a few of these. If you didn't see it, Sean Gourlay from Primer he did a great talk yesterday, and definitely catch that on video if you didn't. There was a Wired article about Primer in recent weeks where they were using some of their AI products, something called Quicksilver, to identify and fix gender bias issues in Wikipedia, specifically where female scientists were underrepresented in bios. And they are doing very, very interesting work at Primer. And I'll leave that to Sean to say in a much more articulated way. But I've had the pleasure of being in-house there for the past few years, and I really love what they're doing. Stitch Fix is also another excellent example. And Eric Colson has given a lot of talks, as well as other people from Stitch Fix, at the AI conference, at Strata Data Conference. And I caught up recently with Eric, and he was talking about 3, now going on 4 production use cases for Human in the Loop for what they do with their main service at Stitch Fix. So essentially, this is AI for fashion, right? They've got fashion experts along with machine learning algorithms that are working together, and these kind of feedback loops to help really personalize for individuals what kind of clothes to be sending out to them. Another case study in a bit more depth is Figure 8. And I know that Luke, who's the founder of Figure 8, was giving a talk a little bit earlier today. He does fantastic talks in this area. There's a free mini book that was really a case study about Figure 8 back when they were called Crowdflower. And I got to work with Luke almost 10 years ago when he was first launching Dolores Labs, what became Figure 8. And they were really the lone wolf out there. Well, maybe lone wolf is the wrong word. They were the only company that was really trying to commercialize this area a decade ago, to my knowledge. On the enterprise side, Ernst & Young had an interesting report. This is out of late last year, where they were doing compliance for lease accounting. And so what they found was they had 3x more consistency and 2x more efficiency by using human-in-the-loop machine learning when compared with human-only teams. And of course, as a consultant at that level, the billing on your expert consultants is really where you make your money. So if you can get those kind of multiples on it, you'll be making bank. So it's really interesting to see this kind of technology being picked up by large consulting firms and enterprise. How many people use Lola? Anybody here a customer of Lola? How about anybody a customer of Kayak? Okay, more Kayak people, definitely. Paul English and some of the crew out of Kayak have another venture that they started 3 years ago. Basically the Kayak idea, but then using human in the loop with expert travel agents. So they can give a real premium service by having the expert travel agents in the mix. And it's kind of a reversal of AI taking away jobs. It's actually creating jobs or premium jobs for expert travel agents. And it also allows them new capabilities that they didn't have at Kayak. Like for instance, now they can book on Airbnb in Southwest. They weren't allowed to do that before, but now that they have the human delegation in, it opens up more use cases. So there's some really good writing coming out of that crew. And Amanda Kasari gave a great talk yesterday about SAP Concur, and there's something called Privacy Bot that they're working on at Concur Labs, also using human in the loop in some of the difficult areas of understanding travel and expense policy. And I can tell you from having worked at O'Reilly Media that can be very difficult, actually. I'm still thinking about whether I'm going to get reimbursed for laundry this time. Moving along, another speaker here at our conference was Eli was in our blockchain summit on Wednesday, and he has a company called HCAPTCHA. Are people here familiar with reCAPTCHA from Google? So HCAPTCHA is a way of doing this with human in the loop, essentially. So they will have customers come in with data sets that need to be labeled, and then they've got websites, publishers on websites, who essentially are part of their network, and then the consumers who need to be proven to be human on those websites will be engaged in labeling the data. And it's not exactly that. It's a little more convoluted because they have to do a lot of quality assurance and prevent against different types of attacks, possible attacks. Eli has some great stories about that, but I tried to capture it on a bit of a tweet log day before yesterday. So another good example of human in the loop. Crowdbotics, I talked with them earlier in the year here in San Francisco. They're using human in the loop for code generation and as well as test generation. And so the idea is they can work in React or Ruby or Python. They can work with your product managers to take specs and then articulate specs into more of an epic and then break that down into like some of the areas of code that need to be developed in more detail and then begin developing code because they can do this with machine learning along with expert programmers and some product manager expertise in there as well. And it's interesting is they're really taking advantage of your team's history on developing projects. And they get like 1.5x on software developer throughput by using this. SkyMind, Adam is not at this instance, but he's often presenting at AI conference. And we got to catch up. They're doing work for I can't mention the name, but it's a very large telecom in Japan, and doing their anti-fraud. And the interesting thing there, if you're familiar with deep learning, they were overfitting variational autoencoders as the way of basically kicking out the edge cases that they needed to have experts weigh in on. So they basically had worked this inside of the deep learning algorithms that they were using in production in telecom. Another one, Adam Marcus, B12, they create business websites, but they also maintain and update the content on your business website. And so they do this with active learning, and Adam has done some great presentations about it. A lot of it is really, I think a lot of the magic that they have is really centered around some of their project management pipeline. And so they have a GitHub project. They've open sourced that. It's called Orchestra for human-in-the-loop project management in this area. Really fascinating work. And there's an example of one of the automatically generated sites. And it's interesting, too, because the AI parts of this really take the project through the pipeline. It's really only at the last stages that the developers get involved, from my understanding. Jason Laska from Clara Labs was presenting a little bit earlier today. I got to catch part of that talk, and he's given great talks before about this. They have, I guess what you'd say is kind of a two-sided marketplace, where you could have tasks that need to be performed, and on one end of the spectrum, the tasks are something that can be automated, therefore machine learning picks it up. On the other end of the spectrum, it's too difficult for algorithms to take, so the people take it. And across that continuum, across that spectrum, then, you can have an economic basis for it. So, I mean, if the price drops too low, the machines take it, basically. But if the price is high enough, then the people take it. So it's this kind of evolving market for what can people do versus the machines who are active on the same project. There's a really great quote I love from, I believe, Michael Achillean, I believe is CTO of Clara Labs. The trick is to design systems from day one which learn implicitly from the intelligence which is already there. So another way to say that is if you have a system and you have your people, your experts in your domain, they already have a lot of intelligence about this. So how can we design systems that don't just displace that, but rather incorporate it and take advantage of it and amplify it? That's a really good perspective, and it is where some of the elements of design and cybernetics start to come in. Okay, so there's a bunch of different companies working in this area. I think we'll see more. I definitely wanted to provide a lot of resources. Let's dig into a little bit of the theory and tooling. And so the first thing is rolling the clock back about 100 years in terms of business theory. Anybody read this by Frank Knight? I don't know, I doubt that this is even quite a textbook these days in B schools, but 100 years ago, Frank Knight had a really quintessential text called Risk, Uncertainty, and Profit. And it was an early text in business that sort of articulated the Rumsfeld thing of the known knowns and the unknown unknowns. And what Knight was saying was you can divide some of the domain into risk, known risks. And if you have that, there's no upside. You buy insurance. And so once you've factored that out, then you've got uncertainty. And so it's in those regions of uncertainty where you have the profit opportunities. So a lot of what you're going after in business is essentially that people will talk about risk reward, but realistically you're going after uncertainty. And so if you can explore uncertainty in a fairly systematic way, then you've amplified a lot of the business of business. And whereas we think about supervised machine learning, we think about machine learning models being used to generalize from the data they've been trained on, so that they can detect patterns, so that they can estimate labels. But what we're talking about with active learning is to essentially use machine learning models to focus the lens within your data to find out where are the regions that have the most valuable uncertainty. That's also strongly associated with where are the profit opportunities. So how can we focus the lens to find the right parts of the data to get your experts to weigh in on? And again, incorporate those feedback loops in a very systematic way of having people and machines together on a team. Does that make sense? Good, I'm getting some nods. Last few times I said that, I must not have said it right. Didn't get nods, but this time's good. There are different forms of uncertainty if you dig into this. I mean, there's clearly noise versus missing pieces, aleatoric versus epistemic. And there's a few other factors too. One of my colleagues, Bart Ramsundar at Computable Labs gave a talk at the Blockchain Summit this week, where he was talking about AI native solutions, where machine learning models could actually make requests for data. And again, if you think about it, if the model can identify different regions, like a gradient of uncertainty in the data that it's been trained on, then it does make sense for models to be able to issue requests for some of the premium areas of uncertainty. If you really want to dig into the theory, Burroughs Settles wrote the main survey paper in this field, Active Learning Literature Survey, sort of eponymous there. But basically, there's a half dozen or so different variations on how you can identify where the uncertainty is. Where do you make that decision to kick back an edge case to the experts? Because that's going to be expensive if you want to do it right. So there's different variations on this, and certainly since 2010, this has been updated. As I mentioned, SkyMind is using variational autoencoders, actually using deep learning as one of these methodologies now. Now, as far as implementations, there's been open source going back to John Langford and some of the work on Vopal-Wabbit. That's been in there for years. Anybody here ever done an implementation with Vopal-Wabbit? Aha, yes, of course we have. Yeah, not my favorite, but really interesting work. So a little bit easier is the people from Spatie. Spatie is one of the best packages for NLP now. It's in Python, and it comes from a company called Explosion AI, Matthew Hannibal and Ines Montani out of Berlin. And they've just issued a new commercial tool. It's called Prodigy. And so it's a form of active learning. You can integrate it with your Python workloads to be able to do annotations. And in the recent release, on the right-hand side, there's a tweet from just a little bit earlier today, I believe, or at least it came up in my feed today. But they've been working to build out more scale with Prodigy and do more of a team solution. So I think this is getting much more ready for enterprise. I have a friend who's a committer on some of their projects, and I'm really excited to see what they've been working on. Okay, other theory going into practice is model interpretation, and I hope to make that case, if I have time, in just a little bit here. But if you have people and machines working together, you really want to think of that as a two-way street. There's a lot that the machines can learn from the people, obviously, through active learning, and there's a lot that people can learn from the models through interpretation. Interpretation is a slippery slope. Interpretation doesn't mean the same, or machine learning model interpretation means different things to different people. So the use of interpretation in finance is something very different than the use of interpretation in legal, and very different than the use of the interpretation in medical. And if you try to use those consistently across different domains, you get in trouble in a big hurry. But there is a lot of great work toward this. I think, in particular, Peng-Weng Kuo and Percy Liang, some of that work out of Stanford, I believe Percy's been down at Stanford, on influence functions is really interesting. And to put a easier veneer on top of this, there's an open source project called Skater. It's in Python, and it wraps together a lot of different strategies for model interpretation under one umbrella. So basically, you can throw it a black box, and it will come back and probe. Interpretation is not simple. There are issues about global interpretation versus local interpretation. One of the authors of Skater has an excellent video about this, Premit Chutari, and I've worked some with Premit on Jupyter and other aspects, but he has an excellent overview of it here, and I highly recommend checking out Skater. It also includes things like Lime and SHAP and some of the others. Premit and also Samir Singh at UCI, the three of us did a webcast about this recently. And another thing in terms of practices, this came out of Deloitte late last year, and it's what they were calling the no-collar workforce. And they'd done a survey basically anticipating human in the loop. Well, how much is your HR department involved in that? How much is your HR department anticipating the problems that they're going to have to confront in terms of having teams of people and machines together? And how are job descriptions changing, both for the the humans and for the machines. And it may sound trivial, but it's not. It's a very non-trivial problem. They found that only about 17% in enterprise were even thinking about this yet. But I have a hunch this is going to sneak up on people. So that's a good, I expect to see more of this kind of discussion, but it's a good article. Okay, now to get very strange, we'll talk about social systems. There's decades worth of work. Going back to some of the really early work on machine learning, Norbert Wiener, really going back into the 20s on control systems. But circa World War II, Norbert Wiener is famous for having worked on tying together anti-aircraft systems and radar in the Battle of Britain, where we had some of the first automated systems in World War II for targeting. And after that, he went back to MIT, and he did a very strange thing. He was an engineer, a quintessential engineer, but he invited some biologists to MIT. And so that was the team of McCulloch and Pitts, the first neural network researchers. So he is responsible for getting neural networks started. But he also had articulated a whole lot about cybernetics. And it was very early. It's what we call first-order cybernetics. And he has fascinating books on the one about control and communication in the animal and machine. And the other one is called Of Human Use of Human Beings. Really, really interesting dialogue post-war about ethics and automation. And that led to something called the Macy conferences, which was really taking a look at very complex systems and how they tended to fail in unexpected ways. And that was important whether you're working in sociology or developing nuclear weapons. So they had a really interesting cross-discipline series of conferences, which led to a change. So I love this quote. This is from Paul Pongaro in Palo Alto, describing that era of MIT when they were kind of moving into second-order cybernetics. And the thing that really captured it for me was the organism was no longer an input-output machine. The organisms they were studying in early neural network research they were looking at a loop of perception. So the loop would go from perception to action, back to perception again. And again, this really translates. You have teams of people and machines who are working with perception. Deep learning is very much about perception. Action is very much about the outcomes in business. And that kind of loop is where you, again, figure out what parts of the machine is going to do versus the humans. So getting away from that kind of linear flow of input-output to feedback loops was a very important conceptual hurdle. There's a lot of great material in this area where biology has been informing computer science, again, starting with some of the early work in neural networks. Some of the people there, how many people have ever seen about Project CyberSyn in Allende, Chile? Yeah, so one of the grad students on the original McCulloch and Pitts neural network research project, his name is Umberto Maturana, and he showed up as one of the team leads in Project CyberSyn. And he has Maastricht. He has this great institute down in Chile now. If I can just carve off a year to go. Along with one of his grad students, Maturana and Varela wrote a book in the late 70s called Autopoiesis and Cognition. And his boss was somebody named Fernando Flores, who had led parts of Project CyberSyn and was a political prisoner as a result after Henry Kissinger got done with him. Not to get political here, but basically Stanford and Berkeley worked to get Fernando Flores out of prison. They brought him up to a lab to work with Terry Winograd. And so there's some really great outcomes there. Understanding Computers and Cognition was an excellent book out of 1986 about early groupware. And by the way, one of the projects that came out of this lab that Winograd was working on is something called Google. You might have heard of. But in my read of it, there was a lot of information there about, again, how to get teams of automation and people working together and this kind of feedback loops. Conversations for Action is a really great book by Fernando Flores that his daughter helped to curate. And along with this, you had a lot of interesting people like Greg Bateson and Margaret Mead weighing in as well. So action comes from committed interactions of people making requests and promises in networks of commitments. And I think that this is much more of a pattern for what we see in enterprise use cases than input-output with a black box in between. So a lot of great work there from Fernando Flores, and I think that has had a more significant impact in computer science than we probably are yet to acknowledge. Okay, how this all matters, let me wrap it up real quick. Second-order cybernetics is pretty esoteric. It began as a study of how complex systems fail, also about how social systems and physical systems, what do they have in common. A lot of this helps provide foundations for AI systems of people and machines, and it's very applicable for what we're seeing in AI adoption in enterprise. The thing is really feedback loops, as conversations for action, as Flores would say. The participants are not detached from the system, they're part of it. And again, that feedback loop from perception to action back again. It's very critical. I think that from the big data era, and I'll probably share some blame in as being part of this, in big data we were thinking about very linear flows. We would typically have a directed acyclic graph. We'd have some big graph of what needs to be processed and the outcome. And that was great because we were working with batches running on clusters, Hadoop, that kind of thing. It led to notions of data-driven organizations back, I guess DJ Patil and others doing that in like 2009. It led to machine learning optimizing for objective functions and how do those tie in with KPI for product teams. It led to notions of, hey, we should avoid garbage in, garbage out. A lot of these are very linear kinds of thought. And they were good in the day. They were a very sound approach because we were coming out of an IT backdrop even before really cloud had been accepted. We were coming out of an IT backdrop where batch processing was the norm, business intelligence was the norm, et cetera. However, those ideas in context have much less ROI today. So what's coming up in the landscape with active learning use cases, especially in enterprise, is more about the circularities. And that's a lot of what cybernetics said was, don't fear circularities, embrace them. The observer is part of the system, and stop thinking about this kind of linear input-output. And instead, this is more analogous to what we talk about in the military as far as the OODA loop. But it's one in which the OODA loop includes automation. You definitely recognize multiple feedback loops. And again, conversations for action are a pretty good template for this if you go back to Flores. And I think that a real key here is that when we're describing systems and coming up with product statements and requirements, we need to pay attention to the verbs that are being used as opposed to the nouns. And that's actually quite a change because in the past 15, 20 years of data warehouse theory, we focused entirely on the nouns. We talk about fact tables and schemas. It's all about nouns. The relationships are very, very trivial. But I'll let Edgar Cod say more about that. But anyway, I'm trying to show here a diagram where you have your human experts on your team, and they can provide examples, take actions. They can provide, decide about edge cases that feeds into the models in the middle column. The models help to focus where are the areas of opportunity, where are the areas of maximal uncertainty, if you will, that has use case tied to it. And so machine learning models are learning from the experts, but also through interpretation methods, you can gain insights back from the machine learning models to feed back into your organizational learning. And we've seen this in use cases. I saw this at O'Reilly Media where we had a real problem with annotating content, learning content, across 200 publishers. How do you annotate correctly when you have a lot of material coming through? And you can train people to do it, but you also want them to get training back from the machine learning models that they've helped to train. So you want to get that feedback loop coming back into your organization. At the same time, the models are interacting with the customer use cases. And so they are providing actions, decisions when possible, or if they run into enough uncertainty, they're kicking it back to the experts. So then you've got this community of your customer use cases as well, and hopefully they're providing feedback into your team. Hopefully you have other parts of your organization like sales and training and service, et cetera, that are going the other direction. So essentially this diagram is trying to capture two-way interactions at every point of contact as a way of representing complex feedback loops that apply in enterprise. And again, going back to the CTO from Clara Labs, design systems which learn implicitly from the intelligence that's already there. I think that active learning provides a lot of guidance for how we can augment AI in enterprise. And with that, if you want to get a hold of me, I've got a whole bunch of publications and video interviews and conference summaries and whatnot here. Catch me on Twitter especially. And thank you very much.